Hello students, so today I would like to tell you about my very favorite molecule. Now, there's some different contenders for my favorite molecule. There's caffeine, the obvious choice. There's theobromine, which is a chemical in chocolate that I really like. But no, my favorite molecule is water. So these three little atoms, the way that they are put together and the properties that they have allow life to exist, and that's pretty great. So by the end of this video, we should be able to describe the properties of water that make it essential for all life. Let's start by just looking at the chemistry of water. So in this whole next section, we'll be looking a lot at chemistry, and so hopefully a lot of these ideas will come back to you from your previous studies of chemistry. So first, if we have water, it's H2O, meaning there's two hydrogens, there's one oxygen. If we think back to chemistry, hydrogens both have one valence electron, oxygen has 6, hydrogens want 2, and oxygen wants 8. Therefore, the hydrogen and the oxygen are going to share electrons in between, forming a covalent bond. However, oxygen is a whole lot more electronegative than hydrogen, meaning oxygen really likes to hold on to those electrons, where hydrogen doesn't nearly as much. Therefore, this covalent bond between the oxygen and the hydrogen is not going to be balanced. The oxygen is going to be holding on to electrons more. Because of that, the oxygen is going to end up being just a little bit negative. So the symbol that we use to show it's a little bit negative is this one right up here. The hydrogens, on the other hand, are going to be just a little bit positive, which we indicate with this symbol. That uneven sharing of electrons is really the basis for all of the incredible properties that water has. We call that polar. So whenever a molecule is unbalanced with its electrons and has a slightly negative side and a slightly positive side, we call it polar. Throughout this whole unit, whenever there's a question about water and its properties and you ask why water, the answer is always because water is polar. Because water is polar, it's going to have this ability to create some additional bonds called hydrogen bonds. So if we look at water here, there's the slightly positive side. That slightly positive side is going to form a weak attraction with the slightly negative side of another molecule. That's a hydrogen bond. That's going to hold these things together. Now, hydrogen bonds are fairly weak, but when we're looking at a large number of molecules, it explains so many properties about water. So we see that again here, where this oxygen side is connected to the slightly positive hydrogen. We could even draw a bunch of those. Here's an oxygen with two hydrogens in the middle. The hydrogen is attached to an oxygen, then that hydrogen is attached to an oxygen, etc., etc. Okay, because water is polar, and because water forms hydrogen bonds, it has a bunch of properties that make it really great. So these are just my top 7. There's more that make water really awesome, like the fact that it's see-through. It's actually very important for photosynthesis. But these are my favorite reasons why water is the very best molecule. First of all, water is really great solvent. That means it's really good at dissolving other stuff. Now, it's not good at dissolving everything. It's just good at dissolving other things that are also polar. Because water is super polar, it's really good at getting in between other molecules and breaking them apart. Anything that's dissolvable by water, we call that hydrophilic. If we break this down, hydro means water, philic means you like it. So hydrophilic are things that like water. Hydrophobic is sort of the opposite, where you have hydro, water. Phobic is something that's not liked. And so these are going to be all nonpolar molecules that don't dissolve in water. We see hydrophobic interactions a lot in biology when we're looking at membranes, we're looking at lipids, which we'll talk a lot more about later. Here's an example of how water will get in and dissolve something. So here is NaCl, that's salt, which is dissolvable in water. So what happens is these little water molecules with their slightly negative side and their slightly positive side are going to get in between these, where the slightly positive side is going to surround this negative, the slightly negative side is going to surround this positive, and that's going to break those things apart. That's dissolving. Because water is a great solvent, life can exist. And why is water a great solvent? Because water is polar and it forms hydrogen bonds. The next reason that water is really awesome is because of a term called cohesion. So if we break up this word, co means together, like co-worker or colleague. Hesion means sticking. So cohesion is sticking together or sticking to itself. Water is really good at sticking to itself because of those hydrogen bonds. Because water can stick to itself, surface tension is a property that water is going to have a lot of. Surface tension is used in a lot of different ways. One way is this little lizard who is able to run on top of the water. He's moving so quickly that the bonds between the water are holding him up. We see that a lot with water striders. We see that in a lot of different places. The fact that water forms droplets is because of this, because it has a really high cohesion. In addition, water has really high adhesion to other things that are polar. So ad means something else, like adhesive is like sticking two things together. So adhesion is when water sticks to other polar substances. So cohesion is water to water, adhesion is water to something else. Because water sticks to other stuff, it's going to have this property called capillary action. So capillary action is just in very small spaces, water can defy gravity because it's going to stick to the sides of these small spaces and it'll climb up against gravity. We see this in really small tubes. Now there is a limit to this, but if we have a really small tube, water can go further up, and a tube with a larger diameter, water can go less far up, but water can go against gravity. That's going to be really important in transpiration. So transpiration is a process used in plants. Trees, if we think about these giant trees that are really tall, they don't have a heart, they don't have a pump to move around all the liquids that they need. Instead, they just use the fact that water is cohesive and adhesive to move it around. So transpiration, if I see a tree like this, water is going to be absorbed into the roots, and it needs to make it all the way up into the leaves. The way that it does that is in the leaves, there's going to be little pores called stomata where water is going to be evaporated into the air or used up by the plant. And then as that water is pulled out, the next little water molecule is going to stick to the one before it and pull it up. And because it also has adhesion, it's going to stick to the outside of these little tubes, allowing capillary action to occur. That occurs all the way through the tree, from the leaves down into the xylem in the center of the tree, all the way down into the roots. That allows water to go all the way up into the top of the tree. Just one reason why adhesion is super awesome. Okay, another reason that water is really, really great is because of its thermal properties. Water is really, really good at resisting change in temperature. And the reason for that is heat is absorbed by water at a really, really high level before the temperature of water actually changes. So if you look at this little diagrams down here, these are showing all the different ways that water, the molecule, can wiggle. And as water, the molecule, is wiggling, it's absorbing a bunch of heat, but it hasn't actually created the whole molecule to move around more, so it hasn't changed the temperature yet. We call that specific heat. And so water has a really, really high specific heat, one of the highest of things that we know of. For this reason, the temperature of the whole planet Earth doesn't change that much, and it's going to change even less if there's more water. I want to illustrate this really quickly, looking back at our biomes that we studied before. So I just want to look at two of them, the rainforest and the desert. So if we look at the rainforest, its defining feature is that it has a whole lot of rain. But if we look at the temperature range here, it's only between, I don't know, maybe 60 and 80. That's a pretty small range because it has so much water. Versus if we look down at the desert, which its defining characteristic because it has very, very little water, it's going to have a much larger range going from 20 to 100. So this really, really large range going on here. The reason the desert has a larger range in temperature than the rainforest is because there's less water there. Water has a high specific heat, so it holds on to the temperature. Because our planet is covered in water, our planet has a temperature that's within a fairly small range. The next thing that's super awesome about water is that solid water floats on liquid water. That is so rare. Most of the time, solids are more dense than liquids, and so they'll sink. Water doesn't do that. Instead, ice is going to float on top of water. That's important for a bunch of different reasons. One reason is that in the winter, in cold places, there's going to be a layer of ice that forms on top of the water. That's going to act as an insulation, and that allows below that to remain liquid. So that allows, fish to survive throughout the winter and other things to survive throughout the winter, and prevents the whole planet from turning into a solid block of ice. In addition, if all of the ice on Earth were to melt, sea level would rise a whole bunch, and we would have a lot less land overall. This little diagram here shows the density of water. Notice that the highest density of water is when it's a liquid at about 4 degrees Celsius. And as it gets colder and colder and colder, the density goes down. And so this would be ice here floating on top of water here. This is as the temperature increases and as the temperature decreases, like that. Pretty cool. Okay, another cool thing about water is it has a neutral pH. So if we remember our pH chart, anything less than 7 is acidic, anything greater than 7 is basic. Pure water is right here in the middle, and all waters that exist, like rainwaters, can be a little bit acidic. Sometimes we have alkaline waters be a little bit basic, but most water is going to be right here in the center. That's going to be important because so many chemical reactions with drive life are really, really based on pH. All right, the last awesome thing about water is that it is the only natural substance on all of planet Earth that's found in all three physical states, so as a solid, as liquid, and as a gas, at temperatures that are naturally found on Earth. And so other things can be found as solid, liquid, and gas, where you have to heat them up really, really high, or you have to put a bunch of pressure on them, because remember, state is based on pressure and temperature. Because water can do this, it allows our water cycle to occur, where there's a liquid water that'll be, evaporated into a gas phase, which will then turn back into a liquid phase. Sometimes it can freeze in there and then join the liquid again. The water cycle and the movement of water within our planet is largely because of this awesome property of water that is found in all three physical states. Okay, so I'm going to stop there talking about some of the awesome things about water. All 7 of those things. If I ask why does this happen? The answer is because water is polar and water forms hydrogen bonds. But because all 7 of these things happen, life is possible on planet Earth, and I think that's pretty great. And I hope you do too. Hopefully that helps.